Okay, so let's start today's class because the time is up. So we should be starting now. Okay. Am I audible to everyone? My screen is visible, right?
Yeah, we can hear you, and the whiteboard is up.
Okay. Okay. So till now, what are the things that we have covered? First thing, on the first class itself, we covered about the basics of CPUs and cores and how RAM and disk is allocated and what is the basically working of the computing units and how they distribute the work. Then when we come actually in the course, we studied about the cloud computing itself and we saw what is the definition of cloud computing. So I'll just mention the topics and I'll discuss a bit so that we don't consume a lot of time here on making the revision. So we discussed about cloud computing as whole, and we said that it's on demand resource delivery over internet, and you pay for the things that you are using. Okay, so you pay per use on cloud computing. And we also discussed about the advantages that cloud computing is providing over the uh, in-house servers and the when you have something, when you have some business, you can set up the in-house servers, and at the same time you can have the cloud computing also. But when we compare like the cost and the problems and the management issues that are coming in the in-house servers, in setting up the in-house servers, in terms of the scalability, in terms of the flexibility, we found that cloud computer provides the better opportunities to us. Then we also discussed about the various benefits, and we took small examples for to explain those benefits as well. And we saw how the cost saving and the closer proximity to your end users can actually benefit your business or the business of the client to grow in a better way. And after that, we also discussed about the service models. So we studied about three service models. Three service models we covered, cloud computing service models basically. And on those three service models, can you just quickly tell me what were those three service models that we studied? Anyone, please? Three service models, three cloud computing service models.
So we have infrastructure as a code, sorry, as a service,
Service, yeah. Then platform as a
platform
service,
service, and
then
software as a
software as a
service.
service. Okay, so three service models we studied, and we said that these service models are classified in terms of the control, flexibility, and management rights that each service models are providing to the client itself. And we found that if you talk about the flexibility and control, lot of flexibility and control is available on infrastructure as a service. And then comes the platform as a service, where you will not be required to manage the underlying infrastructure. Usually the vendor manages the underlying infrastructure, and you will be more focused on the deployment and management of your own application. So the flexibility is there, but it's not a lot of flexibility that is available to you in terms of the infrastructure here in platform as a service. And then we talked about the software as a service, where we saw that it provides the complete product that is run and managed by the service provider itself. like like you have end user applications, for example email service you are having. And then we also saw that here in software as a service, you would not be required to worry about how service is working and the infrastructure is involved. Everything is basically provided and monitored by the vendor itself. You just need to use that service and pay for it. And then we also talked about something called deployment model, right? So we talked about three deployment models, cloud computing deployment models. What were those three cloud computing deployment models? One, we can have deployment over public cloud. Then we can have deployment on private clouds that we also called on-premises deployment. And then we studied about hybrid cloud or hybrid deployment. And we saw that when we talk about the public cloud, it is globally accessible. So because it is globally accessible, the security, in terms of security, it will be less secure. And when we covered the private cloud, we mentioned that it is not having the global or public access. So more level of securities, customized level of securities can be implemented, and thus it provides highest level of security. But at the same time, it covers only okay. And at the same time, it only covers limited population. It doesn't cover the whole, as like in public cloud you cover the global population, you cover large number of population. But in private cloud you just only cover a limited number of population. And in hybrid deployment, we also we saw that it's a mixture of both public and private. So some part of your data will be accessed by public, that is, it will be available globally, and some part of the data that is important or private to you will be available to only specific members of your organizations. And we also saw that when you have the public deployment, the cost is little bit high because you'll lot of people will be using it, right? Lot of people will be accessing it. So running time and the number of requests that will be made to your machine will be high. So the cost will be high. But in private cloud, because small number of people will be using it, less request will be made to your machine. So the cost will be little bit low. And in hybrid deployment method, hybrid deployment model, you are having a combination of both. So it's basically it tries to optimize the cost and the security as well at the same time. Okay, so three deployment model we studied. Then we studied about the virtualization. And in virtualization, we saw that there will be a host machine, and we saw that when there is a host machine, so whenever you will be requiring some virtual machine or some IT resources for yourself, you'll be contacting some vendor. Vendor will be having the host machine, and as per your need, vendor will be giving you some part of the IT resources that it has with him on the host machine, and that some part of IT resource will be allocated to you in in by using the technology that is known as virtualization. And in overall this process, hypervisor plays a very big role because it's a software that will basically automate this whole process. You as a client whenever you as a client will make a request that okay, you need some resource, then there will be some IT resources from the host machine will be allocated to you in terms of the virtual machine. And this creation of virtual machine, allocation of IT resources, when I say IT resources, I'm talking about RAM, disk, processing capabilities, or let's say CPU. And in virtual machine, we say virtual CPUs, vCPUs, and then network bandwidth. Some part of all these infrastructures are allocated to virtual machine, and it is done by the hypervisor. And hypervisor is also known as VMM. Basically, it helps in creating and monitoring the virtual machines for the client, and this virtual machine will be given to the client. Then client can basically deploy his or her application, and then user can access it based on the whatever the deployment method that client has chosen. The users can access it. If the client has chosen the private deployment model, then only few specific number of users will be using it. If the client has chosen the public deployment model, then a lot of people, like, it will be available globally. Okay, so this is the thing that we saw. Now after that, we talked about the different methods of different types of virtualization, and we said that we only specifically emphasized on storage virtualization because it was basically different from all of other types. So the types of virtualizations were, the first one was hardware virtualization, the second one was OS virtualization, the third one was server virtualization, the fourth one was storage virtualization. So we saw that in all of these hardware, OS, and server virtualization, we saw that something that is very similar to this process is happening. And we saw that in hardware virtualization, OS virtualization, and server virtualization, the allocation of some resources is made by by the by the way that it should be shared to some other client, so that whatever the portion, whatever the resources that has been allocated to that particular client, it can act independently. But in storage virtualization, we saw that it's a process of grouping storage from multiple network storage devices. So multiple storage devices are there on the network, and we group the part of some 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 of that storage that is available on different multiple devices that are available on the network, in such a way that it should look like a single storage device. And that is basically implemented using some software applications. So let's say that there is a network, and this is the compute let's say this is a machine, this is a machine 1. Okay, this is the machine 2, this is the machine 3. And what we'll do, we'll take the storage that is available on all of these machines, and we'll take some part of that storage. Okay, and we'll pool these resources, we'll pool these resources in such a way that whatever the resources that you are having, like let's say resource 1 or memory part 1, memory part 2, and let's say this is memory part 3. So you are having some storage, free storage here, free storage here, and free storage here, and you'll pool these three. You'll just try to group these three resources in such a way that it should look like a single resource, where you'll be having part 1, part 2, and part 3. Obviously it is not done physically, it will be just made to the user, so that it can see that this is the storage that is available to him, and it will be acting as a single storage inside the network. It will be located in different devices, but by the means of the software, like as a software, the client will be able to see that this is a single storage that is provided to him. And this process is known as storage virtualization, because virtually you are grouping whatever the free space that is available in different devices. You are grouping that free space so that it can be shown, it can be it can be it can be represented as a single grouped space to the user. Okay, and then we also talked about the resource pooling. So basically, resource pooling is the concept where uh, uh, you you take the the resource, let's say you are having some resource, and you give the same resource to many people. Okay, so it means that you are multiple customers are served from the same physical resource. So let's say you are having this storage, and then your customers are there, let's say clients are there. Let's say client 1 is there, client 2 is there, client 3 is there. So what you'll do, you'll just share the same resource to many clients. And let's say you are having here, let's say you are having 6 GB of storage, and to your clients you are saying that, okay, you are you can use 3 GB of the storage. Then again you are saying to client 3 also you can use 3 GB of storage. Client 1 also you are saying you can use 3 GB of storage. Okay, so overall you are saying that you are providing 9 GB of storage. But because you know that at a single time, no one initially especially, no one will be using all of these 3 GBs together. So always you'll always have some free space here. But when you'll see that the threshold is reaching, or let's say whatever the aggregated use of memory that these people are consuming, these clients are consuming, if that is getting close to 6 GB, then you'll again add some more storage. And that is basically what happens in your Google Photos, in Gmail, and many big servers are there. Like big companies provide a lot of memory to different clients. They use the concept of resource pooling. Okay. Anyhow, it's simply it means that multiple customers, multiple clients, multiple users are served from the same physical resource. Okay, so physical resource will be same. Like here also, if you'll see, the same concept is happening. The resource pooling is happening. Okay, so this resource is basically shared with multiple clients. Let's say client 2 is there, who is also going to use the same resource. The client 4, client 3 is there. He will also create a virtual machine. He will also use the same resources. Okay, so same resources will be provided to multiple clients. Now, after that, we basically discussed about the disadvantages of cloud computing. And one of the fundamental disadvantages of cloud computing we saw was vendor lock-in problem. Can you explain what is vendor lock-in problem?
You had mentioned vendor locking is, for example, because AWS was, I could say, first on the cloud computing scene. Those initial clients have so much invested in AWS. Their staff has been trained in AWS. Um, they've built, let's say, their infrastructure applications, making use of AWS services. So even if there is another vendor, it's not going to be that easy to switch to that vendor just because of all the retraining, technical skills, a lot of changes in your existing processes, etc. So vendor locking is basically, it's not that easy to just switch to a new vendor.
Yes, correct. And there are a lot of risk also. When you are going to switch, you'll be having basically three kind of risk. That is, one is data transfer risk. So you'll not be able to transfer the data from one vendor to another vendor very easily. You will always have a lot of cost that will be associated. And this is happening because there's no standardization in clouds. There is no common standard rules that clouds are following. The second will be application transfer risk. And the third one that you explained very well was human resource knowledge risk. So basically what happens that in data transfer, let's say one vendor is there, let's say AWS is there, and let's say I'm using Azure. So what will happen that if I have stored certain data on AWS, it will be having different principles, overall different format, different paradigm to handle that data. Maybe the data has been converted to some different format and then it was stored on the AWS. And as the time passed, I stored so much data in AWS. So first thing, it will be very hard for me to extract the data from AWS because the data is so big, lot of data is there. And then it will be very difficult for me to transfer that data and store it in the same format as it was stored in AWS. It will be very difficult for me to store that data on the same format on Azure because the Azure will not be able to provide those standards that are provided by AWS. Maybe Azure is having some different standards. So there will be a lot of cost, uh, lot of support that will be required, and that is why it is very difficult to switch in between the vendors. You cannot easily just switch between the vendors. When I'm talking about the application transfer risk, you can have applications that are using some inbuilt services that are provided by AWS. Let's say the email service, let's say some support APIs, local APIs are there on AWS that you are using so that your business can work smoothly. But when you are changing the vendor, maybe those APIs, those local services are not provided by the another vendor. Maybe it's not provided by Azure. So one thing you can do, you can hire someone and that particular person can code those local APIs manually on Azure also so that your application does not get affected. But again, it will take some time, and because of that lag in your services, you can lose your customer base. And the third one was the HR knowledge, like human resource knowledge risk. So what happens that when you are using AWS, your staff will be trained, your employees are like having very good experience. They have used AWS for years. When you will be changing from AWS to Azure, your staff will require some sort of retraining. They'll be required some time to understand the whole Azure system. So it will be pressure on your staff also, and at the same time, they can take some time. And again, if you are just going to provide some delay on providing the services, it will be it will be bad for your business. You can lose your customer base. So this is the thing that we discussed, vendor lock-in period. So exactly, you were actually correct, Clara. That's a good answer. After that, we discussed about cloud computing architecture. So why I'm revising everything, because in the last class, I mean, you mentioned that we should be having some lecture on which we are revising everything, although you asked that we should be having some recorded sessions. So this session will also get recorded. Okay, so I'm trying to cover it very quickly so that you can also refer this video again in future. So we discussed about the cloud computing architecture. And in there, we discussed about the client interface, and we discussed about the vendor side. So on the vendor side, whatever happens, we said that it's running in the backend. And on the client side, we said that it's running on the front end. And there will be some communication medium that will be provided by internet. We saw that there are certain components, that is application, services, then runtime cloud is there, then storage, and then infrastructure. And there will be some management module and some securities. And we saw, actually we covered how basically how it works. So client will interact on the client interface. It will be the front end that will be available to the client. Then client will be using the applications. So whenever the client will be using the applications will be providing the interface. And through these applications, client will be would be using the services, the 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 service models that are provided by the vendor itself. And using the service model, the client will be allocating some resources, some infrastructure for his own application deployment. And that infrastructure will be provided by the vendor to the client. So this is the overall cloud computing architecture that we have in general, like we discussed in detail also. So this we basically discussed, right? So if you have any doubt, like you can ask maybe after the class, or uh, maybe right now also you can ask if you have something that you don't understand. Okay. So here in this architecture, what happens that client will go and client will interact with the interface. The interface is attached to the applications. Via applications, the client will be making some request to uh, to allocate the resources for him as per some model, some service model that he will be selecting. Maybe he's selecting, let's say, infrastructure as a service. So at that time, maybe he will be requesting for an EC2 instance, so that whatever the infrastructure, whatever the IT resources that would be that will be requested by the client will be allocated to that particular client. Okay. Maybe he's asking, he's trying to use platform as a service. So whatever the let's say elastic beanstalk instance is there, or elastic beanstalk module is there, that particular machine will be allocated to him, and he can just deploy that application to that machine, and he would not be required to monitor anything. Okay. So likewise, maybe he's requesting some software as a service. So software as a service means he wants to use the products that are products or services that are made by the vendor itself. And when he will be using it, he'll be paying the cost, relevant cost that is incurred. So these are the two parts that we saw on the cloud computing architecture as well. Okay. And after that, we basically saw two concepts. One was your serverless computing. So what do you mean by serverless computing? Anyone, please tell quickly. Anyone, please. What is serverless computing? Yeah. Yeah. Am I audible? Hello.
Yes, you're audible.
Yeah. So please tell me, what is serverless computing? I mean, we discussed about it, but we didn't revised it multiple times. Like we revised other concept multiple times.
Um, so basically is when you're able to run like applications without actually provisioning like the instances or the servers for it.
Okay. So yeah, in more simplified way, uh, what it would be. So the thing that you are saying, it's actually done in platform as a service also, right? So in platform as a service, you don't have any instance. You just take your application, deploy it on some machine, on some whatever the server that is provided to you. Whatever the underlying resources are there on that particular machine, that is deploying your application, it's all monitored and it's all taken care by the vendor. And that happens on the platform as a service. So what is serverless computing? Yeah, anyone, like, uh, I know Clara can answer, I know, but I want to know, Brandon, tell me what is serverless computing? So, okay, let me tell you. So when we say serverless computing, first thing that we need to take care that serverless doesn't mean that there will be no servers. Okay, it can confuse you that because it's written serverless computing, so we can think like, okay, serverless means there will be no servers, so no servers will be engaged. It's not like that. Okay, so servers will be there, and it's a cloud computing execution model in which the cloud service provider allocates the resources on demand. So I think we took some example also. We compared how the serverless computing is different from platform as a service uh, model, and we saw that when we are using platform as a service model, we need to pay some cost. Actually, we need to pay some constant cost all the time, no matter if you are not using the platform as a service, uh, whatever the if you have taken that deployment method, the service model as a platform as a service, you have to pay some certain cost, no matter if you are using the underlying resources or not, no matter your application is having some uh, like incoming request, or no matter you are processing something or not, you will always be required to pay some cost in platform as a service. But that does not happens in this serverless computing. So in serverless computing, your whatever the vendor that you have taken, he will allocate resources on demand, and it takes care of of servers on the behalf of the customers. So basically it monitors, it cares for the servers, but whatever the request that will be, let's say you are having some business, and in the business users are making requests, so on the basis of those requests, you'll be you'll be allocated with the resources, and when the requests are down, the resources will be gone. No permanent availability of resources will be there, but on request, they will be available to serve you. But in platform as a service, you'll always have some resource engagement. There will be some resources that where your basically the application will be running, and for that you need to pay some cost. So one major difference is that in serverless computing, this the cost, there will be no cost when you are not using, when the request or when the computational computations are not happening by your applications. There will be no cost if there is no request or there is no computation that is happening by your application. Then there will be no cost. But in platform as a service, you will have to pay some flat fee. Okay, some fee you need to pay, no matter if the request or if the computation is happening or not. If the computations are not happening, if the requests are not coming, then also you have to pay some flat fee on platform as a service. Okay, so that is the thing that we have seen till now. Is it clear? Okay. Basically, these are the concepts that we already studied, so that is why we are not going a lot in depth. Now, we saw that there are multiple cloud computing providers, like AWS is there. AWS is there. You have Microsoft Azure is there. Then you have GCP, that is Google Cloud Platform is there, and then there are some more. But we saw that AWS is having an edge over computing power. So if you combine all these vendors, you will see whatever the computing power you will be getting after combining all these vendors. AWS itself alone, the AWS has six times of that particular, almost six times of that power. So that is why it provides you the cost effective solutions for the cloud computing. Okay, so there are certain advantages because obviously we are studying about the cloud computing. So, and these are the vendors that are facilitating cloud computing. So whatever the advantages that are provided by cloud computing, the advantages will be provided by these particular vendors as well. Okay, so then we discussed about, because it's all about AWS. This course is about AWS. We'll be more focusing on AWS. So we discussed about AWS global infrastructure, and there we talked about the reasons, and then we talked about the availability zones as well. And we saw that reason can have multiple data centers, and these data centers are known as availability zones. And it's actually, it's it's if you see, it's logical actually. If you are having global users, you would like to prefer to set up a data center close to them so that you can reduce the latency. Okay, so latency means whatever the delay that you are having when the communication is made between the two machines. So whatever the delay that you'll be having, that is latency. So to reduce this latency, you need to reduce the distance, geographical distance between the clients and between the servers. Okay, so that is why you are having different availability zones, different data centers hosted on different regions in the world. Now, after, I mean, this is actually the brief that I'm telling you. After that, we started discussing about the domains, of AWS. And on the domains, we were actually discussing about the compute domain. And on compute, we were discussing about EC2. And when we talk about EC2, I mean, the full form itself is like Elastic Cloud Compute. It's the resizable compute capacity. Okay, so you can resize it. So it's resizable, and when you will be having some instance, you will see that whatever the instance that you are getting, it will be a clean slate, right? It will be very clean, like there will be nothing in that instance. You need to install everything. You need to select, like you'll be selecting OS. So after selecting OS, RAM, hard disk, and everything, for the number of cores, you'll be getting a clean slate. So whatever the OS will be there, it will be installed. Some basic functions will be there, and after that, you need to install your local servers, whatever the things that you want to install on your server, so that they can facilitate the deployment of your application. Whatever the things that you'll be requiring, you need to install all those things. Okay, so it will be a clean slate. So it means that you will be the one who will be looking on the support or infrastructure that will be required for deployment of your actual application. So it follows which service model? Infrastructure as a service model, right? And this is the thing that we have seen. Then we discussed how to create an AWS account. So I hope that every one of you have AWS account now, right? And then we looked into the creation of an instance. right? So what happened basically on the last class, so when you'll be having your AWS account, when you'll be logging in the AWS account, you'll be looking at this sort of screen. And then if you want to create an EC2 instance, you'll be required to go on the compute domain, and then you'll be required to click on this EC2 virtual servers in cloud, and then you have to create an instance. So on the instance, if you'll see this drop down, the first thing that you'll be looking at will be the instance. On this instance, after clicking this instance, you'll be clicking on launch instance. So I already have one instance that is running. Okay, so if you want to create some new instance, you'll be required to provide some name. Okay, so let's say I'm giving this name as CC cloud computing. Okay, and then you will be required to select some template that is available. So these are the templates for your machine that is available. You can have your own template. Let me show you from where you can have your own template. uh, I'll be opening it on the new tab. So you can see, if you'll see the launch template, you can create your own launch template. Okay, if you'll click here, you'll be able to create your own launch template where you can browse whatever the available machines are there. You can select what operating system, which with what company combination you want to use. Okay, so you can create your own launch template here. Okay, so for now, let's take one instance. Okay, you can select some free tires. So if I'll click here on the free tire, all the free tire machines will be available to me. Let's say anyone, if I'm taking anyone, let's say 2020 base, and you can see whatever the configuration that will be available to you. So after selecting it, will be, I think then it will be visible. Yeah. So here it will be visible that you are getting one virtual computing CPU. You are getting 1 GB of RAM, and the hard disk you can adjust from there itself. Okay. So this here networking setting that you are looking, you can change it later also. But if you want that there is some network setting that you have done and you want to associate that particular network setting with this instance, then you can select from whatever the security groups that are available to you. So if you'll see security groups, if you want to see the security groups, you can see them, whatever the available security groups are there here on EC2. You see, these are the security groups. So each and every instance that you'll be creating will be associated with security group. This security group handles the security in general. So when I say security, it defines certain rules, and those rules will be controlling the accessibility to your instance. So which IP should be able to access your instance, which kind of port should be opened, what will be the ports that will be opened to communicate over the internet from your instance itself. All those things will be defined here. Okay, so this is one layer of security that you are having, but at the same time, when you'll be creating the instance, you'll be having some local level of security that will be provided by your firewall, whatever the firewall that will be available on your instance itself, that will also provide some sort of security to you. And whenever you'll be setting up the connections, or like opening certain points, certain ports, you will be required to handle these two layers of security first. Okay, so one will be here on the security groups, and another will be on the firewall side. Okay, so let's see, let's go step by step. So for creating this one instance, You'll be required to select one available image that is there. Okay, you can have your own template, customized template. Then after selecting a security group, the network setting or security group. So for now, I'll be creating a new security group, and I'm giving some basic information, some basic, basic rules. So I'm just saying that remote desktop connections or the traffic should be available to my device. Any remote desktop connection should be able to connect to my device from anywhere. Whenever I'm giving this IP 0.0.0.0.0/1, it means I am I'm publicly available, right? So whatever the instance will be created, it will be publicly available to from any part of the world via remote desktop connections. I can select this also. So if I'll select this, it will basically open the port number 443. So HTTPS protocol basically used the secure protocol use the port number 443. Okay. When I'm clicking here, the port 443 will be available to everyone. Everyone can access it. Okay. So like I'll show you. And if I'm just clicking here also, it will allow HTTP unsecured traffic to my instance as well. So port 80 will be open for all the users who are internet. So basically my instance will be will be open for everyone. Okay, it can get connected from every machine via internet. Okay, via these two ports. One will be 443, another will be port 80. Okay, so there also you can edit. Basically you can provide some name to this security group that you are having. You can just name here. Okay, maybe you can just take CC secure. Okay, and this name will be basically available to your whatever the security groups I just shown you, that will be available to you. Okay, these are the rules. Here you can add more rules, you can remove the rules also. Okay, so and I told you about this. Look, I told you about the port 80, right? So for HTTP, the default port that is fixed is this port 80. For HTTPS, the port that is fixed is 443. Okay, and we'll see about these ports later also. Okay, it's not a big deal. And then the hard disk configuration or the disk that will be available to you, you can customize that from there, because we are using the free tier. So 30 gigabytes is only available space that we are having. Okay, and then after that you can launch this instance. Okay, yeah, okay, so we need to, I think we understood in a better way what is key pair. So every instance is having some key. You can say a password file that will be provided to you. So if you have already created some key, you can like associate that key with this instance, or you can always create a new key. So I'm not going to create a new key. I'll just associate the key that I already have. So I'll just use this test key that I already have, and this key will be used to generate the password, and you'll see how. Then you can launch it, and you'll see that it's launched. This instance will be available to your instances. See, CC instances there, and whatever the security group that we created for network security will be available to your security groups here, and that you can use. You see, I created CC secure, right? So it will be available, and you can always see whatever the rules are there. So earlier I defined certain rules, right? And I said that HTTPS connection should be open. So my port is open for HTTPS. HTTP connection should be open. So port 80 is open. And remote desktop connection is also open. So port 3389 is also open. And these are the inbound rules. So when we say inbound rule, it means that we are defining certain rules that will be used when your when your instance is having connection from outside the world, from outside, right, from the internet. When someone or some program, some device, some user is trying to access your server from the internet, then these rules will be implemented. Okay, and there are more outbound rules. Okay, so outbound rule means that whenever your instance will be trying to send something, whenever your instance will be sending something, whenever your instance will be communicating back to the users or back to some service, these rules will be implemented. So it will be communicating based on those rules. And here you can see for outbound rules, I am allowing all the traffic. So any type of traffic, if your instance wants to send any data from any port to anyone, that it can send. It can send. Okay, so I'm allowing everything. You can see all traffic on all protocols. So protocols are like the rules that are followed when you are communicating between the uh, when any communication is established between the devices. Like if there is FTP protocol, there is TCP protocol, right? So a lot of protocol are there. Okay, there is I think SMTP protocol that is followed when you are sending the messages or mails. Okay, so these are the protocols. We'll talk about the protocols as well, because obviously we need to have some brief knowledge about it. It's not like we need to know everything about the networking and how the things work in networking. So we'll be having only brief things. And here you can see the general details. Okay, over there. Yeah, any doubt?
Um, Dev, no, I'm following. I just have a quick question. So with
Yes,
the outbound rules,
yes.
it should always be for all traffic, or is that best practice to allow all traffic to go out, or it's just for this particular example?
No, it's not best practice actually, but I mean, you can change it also, right? For now, we don't want to have like a lot of customization. So
Mm-hmm.
because this is the first time we are creating instance, right? So for
Okay.
now, we don't want that there should be a lot of customization that we are doing. You can obviously define some IP. Let's say you can have your own IP. You can select here my IP. Okay. So this is my
Okay.
IP right now. Okay. So if you are selecting this only, then your instance will only be able to communicate with your your machine, not all the clients, right? To only your machine. And now you can see how we are relating it. If I'm saying that my instance will only be accessible to some group of IPs, so you see what is the deployment method I'm using? The private deployment method, right? It's not available to the whole global, to whole all the public over the world, right?
Okay.
Okay, so for now I'm just saying that it's available like to everyone. Okay, maybe I can just say that it's available. Yeah, it's available to everyone. Okay, on,
All right.
yeah. So just hold on, I'm getting messages.
Looks like Brandon and Helen dropped off the call.
Oh, yeah. Okay, so once we have these things, once we do these things, like we okay, so you can see that the security groups will be available here. So you can
Mm-hmm.
use this security group again whenever you are creating a new instance. You can use this security group instead of creating one. You can use this security group for any other instance as well. Okay, once the instance is created, okay, we can connect to this instance. I think you asked the doubt also whether we will be able to connect it via the SSH or not. So you
Mm-hmm.
can always have a connection via the terminal by using the SSH connection. For that, you just need to have your uh, uh, is you can have your IP along with the user, or you can have your uh, domain name itself or public DNS address. And via using public DNS address, you can just write some command like SSH, then hyphen, then your address, public DNS address, and then you can give the password, whatever the password that is associated to that particular user, or if you are not using user, whatever the password that is associated with the root, and then you can access the whole instance from the terminal as well. Okay, so in general, like if I'm having, because right now I'm having Windows instance, so on Windows instance you can have the remote desktop client, remote desktop connection. Okay, remote desktop connection is preferred because it saves a lot of time. If you don't know the terminal, if you don't have any idea on like how to do things on terminal, you can have remote desktop connection. Is totally fine, nobody is going to stop you. Obviously it consumes a little bit bandwidth because the the communication will be having some sort of more information. So on the channel you'll be supplying a lot of information like the screenshot shared, your actions, your moving of cursor, and everything will be shared back and forth in between the instance and you. So there will be some more consumption of bandwidth that would be there when you are using the RDP connection. If you are having low network, like if your connection is weak, your connection on the internet is weak, you can always go for the console access or SSH access. Okay, so you need to download this remote desktop file, and to get the password you will be required to upload your whatever the key pair that you created. And I didn't create that key pair because I already had one key, so I associated this test.pem with my instance, so I'll be using this. And then you need to click on the decrypt button here, and you'll be able to get the password. Okay.
So after you upload the key, you click on decrypt. Okay.
Yes, and then you'll be getting the password. Okay, and then using your remote desktop connection, you can just fill out this information because this is the username administrator. Only one user is there. Obviously, you can create many other users as well on the instance itself. When you'll be logging in on the instance, you can create different users as well. But for now, we are only having one user, that is administrator. So you'll be just pasting the password, and this is your public DNS. Okay. When I was talking about the SSH connection, I was talking about this public DNS. And just click on connect and you'll be getting your instance. See, right now, whatever the instance that you are looking at, it's basically a computer. If you'll see, it's just a OS interface that you are looking, Windows. So obviously it is getting prepared. So this will be a clean slate. Okay, there is nothing. You cannot deploy your application right now on in here. You will be requiring some support, services, some maybe if your application is using some kind of services, you will be required to install those services on this particular PC that you are having. Okay, there's a kind of computer that is given to you that is having a global access, and whatever the networking rules are there, they are available to you. You can define those network rules. You can customize the things that are there in this particular PC that is in front of you. So it's all on you. The monitoring, whatever the network, whatever the requests that are coming, resources that are consumed, everything has to be monitored by you. Okay. So if you want your, let's say, website or application to be available all over the internet, you will be required to install a local server in this particular computer as well. Okay, So for now, what I'll be doing, I'll be installing a local server, okay, and that server I usually prefer WAMP, okay. So WAMP server I will be installing because it's actually light and it just has everything. It will be having Apache, it will be having PHP, will be having the MySQL also. So everything will be there in that particular server, okay. So you can install it or you can just download the Chrome first. It will be easy to get the Chrome. I mean, it will be easy. Okay, I don't want to synchronize my data.
So should I be following what you're doing, or I should just?
No, this video will be available to you. It's recorded. Okay, so you can follow it later also. It's not a problem. So here, like this is the browser that is basically on my machine, right? So whatever right now when I'm accessing this machine, I'm actually using the network that is provided by my vendor, right? Whatever the connection is there, if you'll see, if let me just speed test it. Okay, speed test. And see, it's running slow, right? It's running slow. I mean, if I'm looking on my screen, it is coming slow. And obviously, you can also see that it's a little bit slow, right? Why it is
Is this the
happening?
internet inside? Is this the internet inside your instance?
Yes, yes. So that is what I'm just trying to prove here. Okay. So if I'll just see, you can see the speed that is provided by your vendor will be so high. Okay. Why I'm getting this slow feed? Because my internet is weak. Okay. So on my side, whatever the connection that I'm having on the internet is weak. Okay. But the connection that is there on the vendor's device, the instance that is provided by the vendor, it is having very high connection, very high speed internet. Okay. On my side, the internet connectivity is very low, and that is why I am not able to get the whole like video feed or screen feed on my side very quickly. Okay. So internet connection on the side of this vendor, it's very high. You can see 621 mbps is the speed that is provided, right? So whenever you have low internet service, okay, like I don't have very good service. That is why whenever I'm accessing this instance via remote desktop, I'm not able to get the things quickly done. If I'll open something, I clicked here and then it will be opening, it will be visible to me. On the server side, whenever I'm clicking, as soon as the click input is sent to the server, it's opened, it's very quick, but that action is not shown to me immediately. Why? Because there is latency, because my connection to that instance is not very good. Okay. So
Okay.
if you want that there should not be any delay, two things you can do. One, your internet connection should be very good. Okay. Then you can use the remote desktop. It will be working very fine. Okay. The second thing, if your connection is internet connection is not very good, you can always switch to the console, the terminal mode. Create the SSH connection and use the instance from the terminal itself.
I
Right.
have a
So
question.
yeah.
Is it easier to install or upgrade an instance if you do it through RDP as opposed to from the command line and you SSH into it?
Yes, actually it depends. So that is why I told you. So when you are using the remote desktop, you'll be able to see the things. Okay. So if you don't know,
Okay.
you feel like you are good when you look at the things that you are doing, you should be going with remote desktop connection. But there is one drawback, that when you'll be using remote desktop connection, you you may get the delays like the screen feed will be shared to you, so there can be delays if you are not having very good connection. Okay.
Okay.
So, and if you are comfortable with the codes or the commands, that the terminal commands, the script, then you can always use like the terminal to access it. It will be faster and it will be quick, right? Because there will be no feed or visual things that you get on remote desktop. Okay.
Okay.
So we can install vamp here, or let's continue it in the next class. I think we have revised everything till this point, and I think it would be clear to everyone. But because nobody is there, so it would be waste if I'm doing it right alone, if you are doing it. So
Yes.
this is the class for today. Okay. I mean, nobody is there, and I know that if you would have had any doubt, you would have asked. So
Mhm.
let me just stop recording. And okay, how to stop it? Okay, and I'll be